Okay. This is now we're going to be dealing with sum and difference in domain with composites. Well, not with composites, but two different functions being added together, and we're going to talk about some domain restrictions as well. So some things to remember. If I have x to the negative second, that's the same thing as 1 over x squared. X can't be 0. Okay? Same thing with x to the negative third. 1 over x cubed, the domain restriction is x cannot be 0. Remember, x to the 1/2 is the same thing as the square root of x. You cannot have the negative square root of x. So, x can be bigger than or equal to 0 in this case. So let's look at some of these. Find the sum or difference of this. So I have 3x to the 1/3 and 2x to the 1/3. Well, 3x to the 1/3 plus 2x to the 1/3 is 5x to the 1/3. And again, we like to write it with cubed roots instead of the fraction. So we can rewrite this as 5, the cubed root of x. Now my question to you is, what is the domain of this? Well, since it's an odd root, remember, you can have negative numbers under an odd root. So we can have any number possible. So the domain is x is all real numbers. We're not on the bottom of a fraction, and we don't have an even root. Find the difference and state the domain. Well, the difference is very similar. We get x to the 1/3, which is the same thing as saying the cubed root of x, which again, the domain is x is all real numbers. Again, the reason behind that is you can have a negative under that cubed root. Square roots are a whole different animal. Okay, for this one, it's all real again. So let's think about that, all real. But for this one, all non-negative numbers is my domain. It can be all non-negative numbers. So find the product and state the domain. So I have 4x to the 1/3 times x to the 1/2. So I get 4x to the 5/6. And how I got that was I made this 2/6 and 3/6, and then added the exponents together. So when you write that down, now you want to turn that into radical form. So it's the 6th root of x to the 5th. So we look at this, it's a 6th root, so our domain is, we can't take the 6th root of anything negative. So x can be anything greater than or equal to 0. In this case, it can equal 0 because you can take the square root of 0. Okay, but let's look at what happens when we do the other thing. Find the quotient. So I'm going to write 4x to the 1/3 over x to the 1/2. I'm going to turn these into something I'm used to seeing. 4x to the 2/6 over 4x, or x to the 3/6. Well, guess what happens? We get 4 over x to the 1/6. Now, to rationalize the denominator, we would need 5 more of them. So I'm doing this in fraction form. I know on the other notes I did it in radical form, but think about it. I have 1 over 6. I need 5 more to fix this. So my final solution is, I have 4 6th root of x to the 5th over x. So look at my domain here. It's almost the same thing as the first part. The first part is the domain cannot be anything that's negative. So that's true for up here. But because this is x on the bottom, there's one more little part. We can't have a 0 on the bottom. So x has to be bigger than 0. It cannot equal 0 in this case. So the difference between this and this is we have a 0. We can't have a 0 on the bottom of the fraction. All right. So you should be able to use your calculator for A, B, and C. And when I say that, that means maybe put this into your y1 and this into your y2, and then you can do the composite. But what a composite is, just if you wanted to know, f of g of 3. Okay, so first you find the middle piece, g of 3. So that would be 4 times 3 minus 8. 12 minus 8 is 4. So now I'm replacing g of 3 with 4, and I want to know what f of 4 is. So I get 2 times 4 squared plus 5. So 16, 32, 37. Now, you can do it, like I said, with your calculator by doing the y vars, y vars, and I'll show you in class. We'll do that in class. But I don't even know if there's any problems like that, so it's just more of practicing. So let's do f of 3 and then g of that. So f of 3 is 2 times 3 squared plus 5, 9, 18, 23. So we're putting a 23 in for f of 3. So we want g of 23. So we get 4 times 23 minus 8. So 4 times 23 is 92. And then minus 8 is 84. F of 3, that's actually a very big number. Try it on your calculator, but you should end up with 1063. But it's the same principle. Do f of 3, get an answer, and put it back into f to get your new answer. Let's do it without, though. F of g of x. Again, that means I'm putting g of x into f of x. So my f of x is the outside one. So I have 2, and instead of x, I'm now putting in the g of x. G of x is 4x minus 8, quantity squared, because that's what it is, plus 5. Well, guess what? I have to FOIL this. Okay, 4x minus 8, 4x minus 8, plus 5. And keep the 2 outside until the very end. So I have 2 times 16x squared minus 32 is minus 64x plus 64 plus 5. Multiply everything by 2, add the 5. You should get 32x squared minus 128x. And then it's plus 128 plus 5, so it's plus 133. So that is what f of g of x is. Let's do g of f of x. This one's a little bit easier. So now my g is my outside one. So I'm doing 4 times the inside, which is 2x squared plus 5, and then minus 8. So you get 8x squared plus 20 minus 8, or 8x squared plus 12. And that's your final answer for g of f of x. So that is how you do those composites. Now, the important thing for composites is that when you're doing domain restrictions on these next parts, you have to remember that the domain restriction is your final answer plus your input. So first of all, let's look at our domain restriction. This is 2 over x, so x cannot be 0 for f of x. G of x, it's all real. X can be anything. X squared is fine. Alright, so we have to look at this and then the final answer. Well, this is all real numbers, so we're good. F of g of x. So we have 2 times x squared minus 1 to the negative 1. That turns into 2 over x squared minus 1. Well, the domain restriction for this is whatever makes the bottom 0. So if you factor that, that would be x plus 1 and x minus 1. And if that input was a restriction, but this input, we input x squared minus 1, which is all real. So that's not going to come into play. The only thing that matters now is that the domain is that x cannot be plus or minus 1. So it's always the domain of the bottom, or domain of the final answer, plus the domain of the input. But since the input in this case was all real, we're good. Let's do g of f of x real fast. So we have x squared, oh, I shouldn't have said that. We have 2x to the negative 1 squared minus 1. Now, you have to square the 2, so we get 4x to the negative 2 minus 1. The 4 does not move down with the x squared. The x is the only thing with the negative power. So we get 4 over x squared and then minus 1. Alright? Well, what's the domain restriction of this? X can't be 0 on the bottom. What's the domain restriction of the input? X can't be 0. So it's the same thing, so it's still just x can't be 0. Let's close off our brackets. Alright, and then finally f of x. Now here's the one that's important. We have 2 times, we're inputting 2x to the negative 1 to the negative 1. So I'm going to do that first. I have 2 times 2 to the negative 1, x to the 1. Don't forget to put the negative 1 with the 2 also. So that equals 2 over 2 times x, or x. Now if you look at the final answer, you go, well, if it's just x, my answer, then domain restriction is all real numbers, which it is. But you also have to look at your input. What did we input into the problem? We input f of x. F of x itself has a domain restriction of x can't be 0, which means that we have to include that. X cannot be 0 in this problem, or else we can't get to this answer. It's undefined. Even though it works fine plugging it into this final answer, we couldn't do it as a restriction. Alright, so let's do this one more. And f of g of x and state the domain. So we have g is being input into f, so we have 3 times 6x to the negative first minus 9. We get 18 over x minus 9. Okay, I forgot to look at the restrictions here. X can't be 0 here, and here it's all real numbers. If we look at this problem, the final answer, x can't be 0, and sure enough, that's also the restriction of what we put into it. So that's my domain restriction there. Find g of f of x. So I have 6 times 3x minus 9 to the negative first. So I can simplify this further and say it's 6 over 3x minus 9. I can factor that and say it's 6 over 3 times x minus 3. And I can simplify that fraction, which is 2 over x minus 3. Okay, now, domain restriction. What can x not be? X can't be 3. What about f of x? F of x was all real numbers, so we don't touch that. We just deal with the x cannot be 3. So it's both pieces. All real numbers, great, but now we have this restriction because of the 3 at the end, so we have to deal with that. And finally, find g of x. So, what is g of x? Okay, this is 6 times x. Actually, we have to input g of x into itself, so this x turns into 6x to the negative 1, negative 1. This is kind of like the problem we just did. When we do this, we get 6 times 6 to the negative 1, x to the first. 6 over 6 is 1, so you just get x. Now, if you look at your final answer, you think, oh, x can be anything. But what did we input into the problem? We input g of x up here, which has a domain restriction of x cannot be 0. So x cannot be 0, even though the final answer looks like it can. Alright, last thing. A computer catalog offers computers at a savings of 15% off the retail price. At the end of the month, it offers an additional 10% of its own prices, off its own prices. Use a composition of functions to find the total percent discount. Okay? And then, what would be the final price of an $899 computer? Well, first of all, the first thing is 15%. So, the composition here would be C is my cost. The sales price of the cost, the original cost, would be, if we're taking 15% off, that means we're going to be paying 85% of the cost. Now, the final sale price at the end of the month is equal to 0.9 or 90% of the sale price. Okay? So we're going to want to input this into here and see what happens. So, my final price with regard to C is going to be 0.9 times 0.85 C, which means that it's 0.765 times the cost. So, in essence, you're getting about what, 23.5% off. It's not 25%. A lot of you guys think that you just add the percents together. No, because we're taking the second discount off of the sale price, so it's less. So when you're dealing with percents, it's easier to deal with how much of the cost you're actually paying. So we're paying 85% and then 90%. So the total will be 76.5. What will be the final price? Well, the final price of a cost of $899 would be 0.765 times that, and you get $687.74. Now, in real life, you could have just done that piece by piece and not had to come up with a composition of functions, but we're just showing how it can work. All right, and that is all.